Flying past the Earth at this time, we see a vast gray ocean beneath a red-tinted sky, punctuated by volcanoes and small land masses. And unlikely as it seems, life may have gained a foothold already. That life in the oceans that gave birth to it may actually be vaporized many times by cataclysmic bombardments, which have slowed but not yet stopped. Earth has begun to take on its final form, a crust, a skin so thin it would be less than a sheet of paper were the Earth the size of a basketball. And under that, a molten semi-solid mantle that boils in extreme slow motion. And finally, two cores, a liquid iron core pulsing out a magnetic field that helps shield us from a deadly cosmic wind from our sun. And a solid nickel and iron inner core. By now, the remarkable process of plate tectonics has kicked into gear. Though how and when it started exactly, we do not know. For what follows next, you might want to strap yourself in. It's going to be a bumpy ride. Here's how it might have happened. At first, Cretans and one continent called had the planet all to themselves. Then, around 500 million years later, Antarctica took shape. About another 500 million years passed before Atlantica formed. The continents roamed separately until, about 1.8 billion years ago, Antarctica collided with what is now Eastern Antarctica to form Nina. Then Nina, Atlantica, and collided 1 billion years ago, forming the supercontinent Rodinia. After about 300 million years, the three landmasses separated and came back together in a new configuration, Pangaea. Pangaea came apart too. When Pangaea split, and Atlantica split up too. If you're confused, join the club. Even the Earth seems confused. All of this movement made for a host of unlikely neighbors way back when. North America's eastern seaboard once rubbed shoulders with Chile. California and Australia were neighbors, if not connected. And Brazil was either connected to Nigeria or very close. Run the Earth time machine backwards, and you can see why. But no matter how many times you run the demolition derby of the continents, a question remains. What the hell is driving them? Hell, apparently. The force driving the plates is the slow movement of the super-hot semi-solid mantle that lies below the rigid plates. Like hot soup, magma boils in slow motion. Superheated magma rises to the surface, begins to cool, and then sinks back down to the bottom of the pot, where it is reheated and rises again. This cycle is repeated over and over to generate what scientists call a convection cell, or convective flow. But where's the heat source keeping our earthy soup performing its circular gymnastics? Well, most of it is left over from the spectacularly energetic collisions and gravitational crushing that created the Earth to begin with. It's still trapped down there, and it wants out. And there's something else in the molten depths that makes it pretty hot real estate. Radioactive material. The belly of the beast has plenty of uranium and other radioactive elements, all of which release heat as they decay. That decay has significantly slowed the rate at which the Earth is cooling. So what does this mean at the surface? Two things. First, magma being burped up along the ridges, those places like Iceland where the Earth is tearing itself asunder, is pushing the plates in their respective continents apart. Second, what goes on at the other end of those plates, the collision zone, may be equally important. Here, where the heavier plates dive under the lighter ones, yanked downwards by gravity, they haul along their plates back into the oblivion of the mantle. That's what we know. or what we think we know. But the details of what's going on in the deepest parts of the Earth that drive the engine of plate tectonics, we may never know.